Problem number 2 on this practice quiz on rational functions is about this graph over here and trying to understand some of the bits and pieces of this graph that has been given to us that is called g of x. This function g of x is graphed over here, and we're going to describe a few things about this graph. So first, it asks us for the equation of the vertical asymptote. Well, vertical lines go up and down, and the asymptotes are always represented with dotted lines. Remember, those are the lines that the curve will approach, but it will never cross or touch. And so we see a vertical asymptote right here, and it's happening right here at this value x equal to -3. And so that is the equation of my vertical asymptote. Okay, it's a vertical line, but it has the form x equals -3. All right, this is an equation, so it has an equal sign, and that is the equation of this line that represents that vertical asymptote. The horizontal asymptote is this line right here, this horizontal line, and we can see that that horizontal line goes through the point y equal to -1. So that is the equation of my horizontal asymptote. And using this information, and maybe a little bit more than that, we can develop an equation of this function. And we've been graphing a lot of rational functions, and here we're doing it backwards. We're given the graph, and we need to find the equation. So I'll start off with my left-hand side, g of x. And it's got to equal some rational expression over here. So I just need something on the top and the bottom of this ratio over here. Remember where our vertical asymptotes come from. It comes from the values of x that cause the function to be undefined. So I already know that we have a vertical asymptote at -3 at x equal to -3. So I just need an expression down here that when I put -3 in, it gives me 0. Doesn't matter what's on top here. If I put a -3 into this expression on the bottom, I get 0, and then whatever it is on top, I'm trying to divide by 0, that's undefined, and that would generate this asymptote in my graph. Now, on the top, in order to figure out what goes on the top, I got to think of a couple of different things. First, I'm just going to think about the horizontal asymptote. And remember, that comes from the end behavior. So let me just imagine as x gets bigger and bigger and bigger and bigger, this graph gets closer and closer and closer to y equal to -1. So I need to pick something on the top that would cause my graph to approach -1. So let me just think about some really big values of x. If I put 1 billion in here for x, and then I add 3 to that billion, it's really just 1 billion still. So for big values of x, this +3 doesn't matter. Okay, so with big values of x, I would end up with let's say 1 billion on the bottom. And if I want the value of my equation for big values of x to basically be -1, then I need like a -1 billion on the top. So for big values of x, I can ignore this 3. And notice if I have like a really big value of x with this equation, it'd be like a -1 billion divided by 1 billion, and that's just -1. So the equation that I've written here actually does approach y equal to -1 for very big values of x. You'll also notice that if you put a really big negative number in, like -1 billion, I would get like a +1 billion on the top and a -1 billion on the bottom. They would still divide out to be -1. So this function so far meets, it agrees with the asymptotes that I've discovered on the graph. There's one other little bit that I want to make sure to include, and I'm just going to go locate this point. It's interesting to me because it has a y value of 0, and I want to just make sure that my graph goes through that point. So let's just plug in -5 for x and see what happens. If I plug -5 in, I get 5 divided by -2. Okay, if I put a -5 in here and here, I get 5 divided by -2, which is like -2.5. So really, if I put -5 into my equation, I get something down here, which is not right. That is not going to work for as an equation for this graph. So let me just think about how I might modify my equation in order to ensure that it goes through that point. And imagine on the top, I can add or subtract a small number here, and it wouldn't affect my end behavior, and it wouldn't affect the undefined values either. So maybe you're already thinking about it, but if I want this function to equal 0 when x is equal to -5, I need the top of this thing to equal 0 when x is -5. Well, when x is -5, this becomes +5. Negative x would be +5. So I just need to subtract 5 from that piece on top. So let's look at it again. First of all, there's still a vertical asymptote at x equal to -3 because that's the value that causes this function to be undefined. And when I think about the end behavior, I can ignore these small additions or subtractions on the end, and I'm just going to think about -x divided by x, which for really big values of x, this is just -1. And so my horizontal asymptote is intact. And then if I want to identify this point, let me just plug in -5. I get the negative of -5 is 5. So I get 5 minus 5 on the top. That's 0. And then 0 divided by -2 is still 0. So when I put -5 into this function, I get 0 out. And so my function, the equation that I wrote for this function here, goes through that point. So that's a good possible equation for this function.